Welcome to video 3 in our Solutions 1 note packet under net ionic equations. Today we're going to put all of our pieces together and start writing net ionic equations. So as you can see in your note packet, we have 5 steps. And I'm just going to go through those steps, and then we're going to look at 3 example problems. First step, balance the molecular equation. Sometimes this will be done for you, sometimes it will not. But you should always check to make sure that the equation is written and it is balanced. Sometimes you might have to figure out what the products are. Sometimes you'll just be given the reactants. So we have to go back to our Chem 1 skills of double replacement reactions and write our products. The second thing we do, for each compound, we're going to use a decision tree and solubility table to decide what will ionize in water and what does not. Then we write out what is called the total ionic equation. We're going to write everything that ionizes as ions, including what state of matter they are in. Remember, if something is soluble, we write AQ. If something is insoluble, it is a precipitate or a solid. And then we have our gases and our liquids, which will be hopefully obvious. We make sure that we have the correct coefficients in front of everything. If things are on both sides, so we have ions that are present on both sides as a reactant and a product, they have to be in the same state of matter and they have to have the same charge. They can cancel out. And then we write down what is left over and we simplify the coefficients if needed. Things should be always in lowest terms. But there's a little note right down here at the bottom that says if all ions cross out, then no reaction has taken place. If you remember back to our double replacement reaction conditions from video 1, a double replacement reaction only occurs if something is a precipitate, a water, or a gas. So those have to be one of the conditions met for a reaction to take place. So let's go ahead and look at our example problems. Our first example problem here is silver nitrate plus calcium chloride yields silver chloride and calcium nitrate. So the first thing we have to do is look to see if this equation is balanced, and it is not. So if we look, we have one silver, one calcium, but 2 chloride ions. So if we put a 2 in front of there as a coefficient in front of the silver chloride, we're good with chloride. But now that changes our silver. So if I put a 2 here in front of the silver nitrate, that gives me the 2 silver, but it also gives me 2 nitrates. But we're good because we have 2 nitrates on this side. So everything is now balanced. So now we have to go through and look at each compound to see whether it is soluble or insoluble, whether it ionizes or does not ionize. So if we look at silver nitrate and we look on our decision tree, we see it's not an acid, it's not a base, but it is a salt. And with this one, it is soluble. So I'm going to just put an AQ right here to tell me that it is soluble. And then I'm going to look at the other substances. Here's calcium chloride. It's not an acid, it's not a base. We have a cation and an anion, so it is a salt. So we look on our solubility table and we see that it is also aqueous. So I'm going to put an AQ right there. Come down to silver chloride. Not an acid, not a base, it is a salt, and it's insoluble, so it does not ionize. So I'm going to put an S after it. And then I'm going to do the same thing for calcium nitrate. Calcium nitrate is a soluble salt, so I'm going to put an AQ. You can pause this at any time if you want to go through and look at the decision tree and the solubility table to verify that these are correct. So now that I have determined what breaks down into ions and what doesn't, I can write the total ionic equation. You have to remember that these get distributed to everything in that compound. So when this one breaks up, it's AQ, we end up getting 2 of everything that breaks apart. So 2Ag, and Ag is positive. So I get 2Ag positive AQ. And the nitrate is a polyatomic and it has a -1 charge, but we have the 2 in front of there, so we get plus 2NO3 minus AQ. The calcium chloride does not have a coefficient in front, so it just breaks up into its respective ions. So we know calcium is plus 2 AQ, And we have a subscript at 2 on the chlorine, so we have 2 chloride ions. Then we draw our arrow. We're done with the reactants. The silver chloride is insoluble. We wrote an S after it. So that means it does not break apart. So we write it as written. And then the calcium nitrate does break up. So we don't have a subscript in front of it. So we get Ca plus 2Aq and 2NO3 minus Aq. So this is our total ionic equation. Everything that can be written as ions is written as ions. Now we can cross out any spectator ions. If you recall, a spectator ion is an ion that appears exactly the same on both sides. So the same state, for example, 2NO3 minus Aq, and we have 2NO3 minus Aq on this side. They are in exactly the same state. They're both Aq, they have the same charge and the same formula, and since we have 2 of each, we can cross those out. The other thing that crosses out is the calcium. Calcium is plus 2 on both sides, and both are aqueous, so we cross out both of those. What we're left with, we cannot cancel out silver ions or the 2 chloride ions. They do not appear. AgCl appears on this side, but does not appear on this side. So if we write what's left over, we end up with this. Now, we're not done yet because, as you can see, our coefficients are 2, 2, and 2. That's not in simplest terms. So they all cancel out, and we get our net ionic equation, silver plus Aq plus chloride Aq yields silver chloride solid. This is our net ionic equation. This is the thing that's happening in the reaction. The calcium and the nitrate really do not do anything in the reaction. Silver ions and chloride ions meet up, collide together, form this insoluble compound, so they precipitate out of the reaction. Go ahead and try to complete and balance the next equation. So please pause this video now, write out what the products are, and determine what breaks down. What is aqueous, what is soluble, other, what is an acid, what is a base, etc., using your decision tree and solubility table. I'll give you a little bit of time to do this, and when you're finished, I will work through this with you. So, this is a double replacement reaction. If you remember with double replacement reactions, 2 ions, they swap partners. So we're going to switch the Al and the Ba. But we have to write the correct formula. Al in this case is plus 3, acetate is minus 1. Barium is plus 2, hydroxide is minus 1. So the aluminum is going to get paired with the hydroxide. So we end up with aluminum and hydroxide. This is plus 3, that's minus 1, so when we cross the charges, we get that. Aluminum hydroxide. And then, if we look, the barium and the acetate get paired together. Barium, we said, was plus 2, acetate's minus 1, so we end up with Ba parentheses C2H3O2 2. Now we have to go through and look and see what is soluble and what is not. One thing in this is not soluble. So aluminum acetate is a soluble salt, so it's going to break up. Barium hydroxide is a strong base. Aluminum hydroxide is also a base, but it's not one of the ones listed as strong, so it actually remains a solid. So it's going to precipitate out. Barium acetate is aqueous, so it ionizes. So now that we know what breaks up and what doesn't, we can go through this problem and figure out our net ionic equation. We have to first write our total ionic equation. So go ahead and pause this video, write out the total ionic equation, and then we will be able to check your answer. Welcome back. So aluminum hydroxide. Oh, we forgot something, didn't we? Did you balance this equation? If you didn't, you have to go back and balance it. So to balance this equation, we have to put a 2 in front of the aluminum acetate, the 3 in front of the barium hydroxide, a 2 in front of the aluminum hydroxide, and a 3 in front of the barium acetate. So now we have to use these coefficients and the subscripts on the outside of parentheses to figure out how many of each ion we have. Aluminum acetate is going to break up. So we have a 2, and aluminum does not have a subscript. So we get 2Al plus 3Aq. And we have 2 in front and a subscript of 3. So that means that we have 6 acetate ions. 3 in front of the barium hydroxide, 3Ba plus 2Aq. And 3 times 2, the subscript on the hydroxide, gives us 6OH minus Aq. Aluminum hydroxide does not break down, but the barium acetate does. So we get 3Ba plus 2Aq, and 3 times the subscript of 2 on the outside of the parentheses, 6 acetate Aq. Now if we look at this problem, we can now cross out spectator ions. So if we look, aluminum plus 3 does not cross out. 6 acetate, 6 acetate, those cross out. Bariums also cross out. If we look, we have 2Al plus 3Aq, 6OH minus Aq, and 2AlOH3 solids. You can combine the last 2 steps, which is write down what's left over and reduce into the next step. So everything is divisible by 2. So our net ionic is going to be Al plus 3Aq plus 3OH minus Aq yields AlOH3 solid. There is our answer. Our last example is sodium hydroxide and hydrochloric acid. Not only do we have to write the correct formulas for sodium hydroxide and hydrochloric acid, we also have to write down the products. So go ahead and write this out. You can pause the video and then check when you get back. Okay, let's look at sodium hydroxide. That one you should know off the top of your head. It's NaOH. Plus hydrochloric acid, another one you should know, HCl. So when these two combine, the sodium, which is plus 1, and the OH minus 1, the H plus 1, and the Cl minus 1, the sodium and the H are going to swap places. We end up with NaCl and HOH, which is the same thing as H2O. It doesn't matter how you write water, as HOH or H2O. So if we look, sodium hydroxide has that OH in it, so it's a base. And it is one of the strong bases, so we write AQ. Hydrochloric acid is an acid. If you didn't know that, it starts with an H. And if we look, it's a strong acid, so it is also breaking up, so it's AQ. Sodium chloride is not an acid, it's not a base, it is salt. And I think you probably already can figure out that it is soluble since it is table salt. H2O, I guess, could be classified as an acid since it starts with H. And if we write it as HOH, it can also be classified as a base. But in both cases, they're weak. They do not break up. And we know that water is a liquid, so I'm just going to put L on the end. So when we break this apart, we have to first look to see that this is balanced. And it is. It's balanced as written. Always a nice thing. Now these break up, and water does not. So we end up with Na plus AQ plus OH minus AQ plus H plus AQ plus Cl minus AQ yields Na plus AQ plus Cl minus AQ plus H2O liquid. Go ahead and pause this video, cross out, and write your net ionic equation. Let's see how well you did. So our NA's cross out, our CL's cross out, and we're left with OH minus AQ plus H plus AQ yields